Hello, it's Andy here, and welcome back to my walkthrough of the 2019 Sans Holiday Hack. At the end of the last video we met Krampus, who seemed to have some secrets to share, but he wanted us to help him win the Frido Sleigh competition before he'd trust us. This involves defeating a CAPTCHA, which sounds pretty challenging, so we'll start with a quick visit to Alabaster Snowball, as he might have some useful hints for us. Alabaster says his terminal shell has been replaced with something else. Let's see what that something else is by using SU to switch over to his user account. We're presented with a beautiful festive Nyan cat, but there's no way for Alabaster to actually use his account. We'll have to hit Ctrl-C to terminate the process, at which point the terminal boots us back out to our original ELF user session. Each user's shell is stored in /etc/password. And we can see that Alabaster's shell is /bin/nsh instead of the usual /bin/bash. We don't have permissions to modify the password file, but we do have permissions to modify NSH. But an attempt to overwrite NSH with bash fails, and we can see why by running lsattr. This highlights that this file is immutable, just as Alabaster had hinted during our conversation with him. Changing such permissions requires root access, but we're logged on as ELF. sudo-l will tell us whether we're able to run any commands to elevate our access, and sure enough, we're allowed to run chattr. We can remove the immutable flag with this, and verify it's been successful with another lsattr. We can now overwrite NSH with bash, and verify using ls. Now if we try to SU to Alabaster, we're correctly dropped into a bash shell. He's grateful for the assistance and suggests we watch one of the KringleCon talks for help with our main objective of beating the Frido Sleigh CAPTCHA. The Frido Sleigh competition is open only to elves, not humans, so is protected with a CAPTCHA involving 100 Christmas-themed images, and only allows 5 seconds to select those matching certain categories. The logic is that only a true Christmas elf would be able to perform this task in such a short time. That is, unless we can write some code to do the same. Chris Davis, who gave a talk at KringleCon 2 on the topic of machine learning, provides some sample code on his GitHub page, itself based on a TensorFlow example, which performs image recognition. It's capable of determining whether a given image is an apple or a banana, so we'll need to adapt it for our purpose. We'll also need a bunch of training data which suits our CAPTCHA, and a way for our model to interact with this website. Examining the CAPTCHA in more detail shows that the images are not loaded from a URL, but are rather rendered from base64 encoded PNG data strings. A closer look at the browser network traffic reveals that the images and CAPTCHA requirements are passed to the browser in JSON format. Each has an ID, or GUID, and image data, the base64 encoded PNG. The browser response goes back as an HTTP post with selected images referenced by their GUIDs. Here I wrote some Python code to scrape the CAPTCHA requests to get some training data and the labels. You can grab a copy of this code from the GitHub link in the video description. After 10 runs, we're not picking up any new data labels, and we should have plenty of image files, about 1,000. Now these need manually sorting. 15 minutes later, we have over 100 examples for each label. The rest of the scraped images can be used for testing. I've grabbed a copy of Chris's sample code, and just need to install a few prerequisites, copy and pasted from the sample code readme, and then we're ready to train the model. This took about 5 minutes on a quad-core virtual machine. Once training is complete, we need to test it with new data not included in the training dataset. I've just selected 2 of each type of image from the leftovers we had from the manual labeling. I'll rename them just so it's easier to see if the predictions are correct. Then run the prediction script, and we have success. All images are correctly identified as the correct type. Let's see if this works on the actual CAPTCHA system. I've written some more Python code to retrieve a CAPTCHA request from the website, pass the images through the machine learning model, and send the response back. A few warnings appear when running this code, however it works as expected and our response is accepted. We've successfully tricked the website into believing we're not human. The final task is to automate the submission of many competition entries. When we spoke to Krampus at the end of the last episode, he mentioned that he'd already done some work on this piece. Here is what he provided, so we just need to add the relevant parts of our code to the script and run it. The code successfully passes the CAPTCHA and starts submitting winning entries to the Frido Sleigh competition. It doesn't take long to make a winning entry, and a few minutes later we get a congratulatory email. Entering the code into our badge registers this objective as complete, and Krampus shares his secrets. He updates our badge to allow us to teleport to various locations around the Elf University via the steam tunnels. He also tells us that he had scanned the scraps of paper fetched by the turtle doves and stored them on the student portal, but he has now locked himself out. Krampus gives us permission to try and hack into his server to retrieve them, which we'll tackle in the next episode. I'll see you there.